Alright, let's do this problem right here. This one's the last one in our binary search list. This one's interesting. This one is just basically binary search, but you have to work with some interface called mountain array, and you can only call .get, where you pass in the index of the element you want, and then .length, which is only the length of the array. And you have to use binary search because if you call it way too many times, you'll get wrong answer. So that's interesting. So idea is, of course, we have to have a lower bound, but we don't know the lower bound. 3 does not exist in the array, so we return. Okay. The target is okay. If only if so given a mountain array, return the minimum index such that the .get equals target. If such index does not exist, oh, okay. Okay, it's a mountain array where it's the first two values are ascending and the ones are there, and then right after that where all of them are descending. Oh, okay. So there's definitely some, like, we have to find like the pivot and stuff. You cannot access the array directly. You may access the array using a mountain array interface. So there's the get and length submissions. Okay, yeah. So okay, so mountain array you have here. Target is 3. We return 0, 1, 2 because that is the first at index 2 and index 5. We return the minimum index, which is 2. So okay, makes sense. Now we need to figure out the search space. So I'm gonna assume it's 0 all the way to length of mountain array -1. Otherwise, that's it. Or like that's our search space, and then based off the index. Damn. I see. Then okay, so basically we do binary search. We'll be stuck at the middle, right? Here. We need to know if we're on like a mountain array, like if we're on like some pivot right here. So that means the next value is decreasing and decreasing. Yeah, I see. So if we're on the peak, then we can adjust accordingly, right? So yeah. So I might have to call it twice, which I don't know if that's a bad thing, but I know the search space is gonna be from 0 to length of -1. 3 exists in the array at index 2 and index 5. Return the minimum index, which is 2. Okay. So search space, right? Then we have to have some cases we need to find. If we find the element, I don't want to immediately assume that we did, because there could be potentially a smaller one, right? So mark that as the smallest, as the element, or mark save that index, right? Keep shrinking search space. If we hit the peak, meaning both elements to the left and right are smaller, then we can also, we'll make our adjustments based off that, you know. Okay, so let's do that. So we'll say res is equal to -1. Our search space is left r 0. 0 length of, well, I can't say that. I have to say mountain array dot length. Oops. Yeah, mountain array dot length. That's our mountain array. Okay, so mountain array. We'll do -1 while L less than equal to R. Middle is L plus R divided by 2. Okay, so if, right, we'll do value is mountain dot array, mountain array dot get m. So we'll get that. So we have this here, right? So we'll have, oh shit, let's have this here, and then we'll do this, and then if the value, okay, that's simple. Then we do these two. Okay, so we'll do this now. If, turn that, okay. If mid equals val, or not mid, if target equals val, there could be a smaller one, so let's decrease it, but we definitely want to save it. So res equals index, so m. Now let's say if okay, so now we need to know if we're on the pivot. So if we're on a pivot, if we are on a pivot, so meaning we'll do prev. We are calling it a little bit a lot though, but I don't want to. Right, we have next. Oh shit, let's call this next. If prev val current or next, right? If the equality is like this, they're smaller, right? If I want to peak, do something. Else, do something else, right? So let's say you're on a peak. Well, I think we still want to. So first determine if the target was too small. So for example, we overshot, so, and we're on the peak. Probably want to reduce R, right? So that means if the target is greater than val, else L equals m plus 1. Now let's say you're not at the peak, right? Like you're on a normal value and we overshot. It seems the same to me right now. I think I'm doing this wrong. Right? If the target is greater than the val, then we overshot, but you're not on a peak, you're in an ascending order. You overshot. I think I should, so basically instead of this, hold on, I have an idea. Basically, if we find the, okay, so if we find it, then that is the start. That'll be our new L, right? Or this will be our new M. Basically, maybe I can do this instead. We'll find the peak basically here. Find the space all the way to there, and just find the space to there. So like find all the number, try to find binary search here, and then find binary search like right here, 3 and 1. So yeah, okay, this is what I want to do. So I want to find the peak, then search the left portion, then search the right portion, right? So let's do that. Because like I don't really understand what I'm trying to do with this. Like it's getting way too complicated. So let's do it one at a time. So let's first find the peak. So find the peak. Let's call this middle. Current middle, right? Current, so previous, current, next, right? Then basically, so okay, so if let's call this we'll do this, let's call this peak here, right? And we'll do if prev cur next, then it's too small. It's like one of these, right? So we have to sign L equals mid plus 1, right? Else if we're saying prev cur next, right? Like this, prev is biggest, then the middle, then that, then we're too big, so we want to decrement. Otherwise, we break out, because that is the exact peak we're on. We want to be finding this scenario right here, the 5. So I want to return equals M, right? The middle point that we're left off at. Anyways, so now that happens. Now let's do binary search from 0. So we'll do low, or we'll do L, R, or L to L, so L, R to 0 to peak minus 1, right? We want to basically search from here to here. Yeah. So let's search here. So let's do binary search here. So low half. So while L, R, let's be inclusive, I guess. Middle, L plus R. And then we, yeah, basic binary search. So it's like if mountain array dot get M equals target, return M, if I should probably call it once so I don't get right elif if val equals target, else if val equals greater than target, then we want to decrement, so we'll do R equals M minus 1. Else, then we'll do, if it's smaller, then we'll just do L plus 1. And then now we did all of that. We want to do from the peak, so we'll do left to which is going to be peak, so left to right, which is going to start from peak to the length of the array, which was I should probably store this, to be honest. Wait, if it's already 0 index, then I don't need to do -1. Okay. So, then peak to end, yeah. Then we'll do while, this is the upper half, so we know that this is descending. So we'll do less than equal to R. Or actually, it's going to be like this, huh? While L is greater than equal to R, we'll do middle, which is L plus R divided by 2. Then, okay, so for if, let's call this val, mountain dot array dot get m, if val equals target, return m, else if val is greater than target, we want to increase L because we want to go smaller. Else, that means it's too small, we want to actually go up, so we want to become bigger, so we say m plus, actually m minus 1, and then we do m plus 1. And then, yeah, theoretically, we should actually find something. Let's say we can't find anything. We'll just return -1. That should be pretty straightforward. Yeah, low half. Top half, right? So this is find the peak. Find peak, and then let's try. Let's see if I made any mistakes. I just don't know how to spell these days. Okay, that's great. All right, pretty nice. Wrong answer. Nice. Okay. We got -1 because we couldn't find it. Target was 2. See, it was in the upper half, so I think my upper half logic is wrong here. Maybe peak +1. Wait, let me use this test case. So it's wrong, I think. Okay. Okay, then maybe don't include it, I guess. Oh, no. This logic will stay the same. I'm stupid, sorry. I'm stupid. The index is always increasing. It's just when I change my pointer. So, yeah. Right, L is equal to m plus 1. R is equal to m minus 1. This is saying, okay, the value is greater than target. We want to go smaller. Going smaller is actually moving our left pointer up towards the end because that's where we know it's descending. And then let's say it was too, I guess, small, or if the value was smaller than we want to, or the value was too, like the target was bigger than the value, then we want to become bigger, so we want to move R down. Ooh, wait, that doesn't make sense. Hold on. If the value is greater than the target, too big, so shrink your space, go smaller. Shrinking your space is actually, if the value is bigger than the target, we want to go smaller by moving our left. The value was too small. It was smaller than the target. We want to increase, so we move R closer towards the peak. So yeah, that's exactly it. Oh shit, okay. Maybe I called it... maybe I do want to do this. Okay, where is it breaking actually? I don't know where that's breaking. 87. 62. Okay, this one, yeah, okay. Okay, maybe N. Okay, -1, I guess. Okay, never mind. I think it's because we're actually on the index here, so I actually don't want to include them. Yeah. Wrong answer. GG's, boy. Oh, it's because this is an answer here, though. I think this is supposed to be, okay, -1, -1. Okay, let's try that. I feel like it's my peak. Hold on, let me do -1 as well. -2 then? Because I'm thinking I don't want to go too far to the end, you know? Okay, never mind. It's not. I think this is fine. So 0 to peak -1. And then we do peak to end -1. Yeah. I'm missing something here, guys. What am I doing? We do 1, then. Ah, okay. See, this is why I don't want to do. Yeah, this is why I don't. Because, like, look, I could be here, right? I could technically be, like, right here. I call it, like, or I could be at the end, and then I call +1, that would be bad. So, that's why I want to avoid going towards the end. So, let's we start here. Okay, we just tried that. It didn't work, though. Oh my god, I feel like it's a point. Because, like, okay, if I don't want to be definitely, like, right here and do +1. Okay, same logic. I don't want to be on. Like, at lowest, I want to be is here. So I can, like, here. So I can do +2, you know? Or not +2, +1 here, you know? If I definitely don't want to be here. Because if I do that, then that's negative. So, maybe start here. Finally. Alright. See you guys tomorrow.